Welcome to this session. In this, we will be talking about what is cartography, what are types of data, elements of data. Then we'll be talking about maps, the various kinds of maps, why we need maps, and what are the how do we analyze maps or how do we read maps and what are scales. So let's start with what is data. So when we talk about data, usually the data is of two types that we discuss. First is quantitative data and qualitative data. When we talk about quantitative data deals with any numbers or anything which can be measured. The next is qualitative, where we talk about quality. For example, the person is fat, the person is small, the person is healthy. So these all explain quality. And then you have quantitative. I'm 50 kgs, she's 60 kgs. So we are talking in terms of quantity. The next is in quantitative, you have two types of data. One is known as discrete, other is known as continuous. Discrete data is a kind of individual data. For example, what is your shoe size? How many brothers do you have? How many sisters do you have? So that's single value questions. Then you have continuous data where you talk about a continuous numerical value. For example, height, mass. So those are all quantitative data. This is one kind of classification for data. The next classification talks about two approaches. One is ideographic and next is nomothetic. In ideographic approach, what we deal is basically we talk about facts and figures which are unique to a specific area. For example, what is the amount of rainfall in the state of Oregon? Or what is the amount of rainfall in the state of New York? So we are talking about specific data. Nomothetic data, we talk about universally acceptable values or universally acceptable facts. For example, sun rises in the east. So we talk about universal data in case of nomothetic approach. The next concept is of map. What is map and why is it important? If you are studying in a school, for example, this is the premises of your school. This is the building of your school. This is the play area or the garden area. This is the building. And this is the bus route area. And this is the area reserved for events or functions. So what I'm basically trying to do is, I'm trying to show a map of the school. So that is, whatever we are able to represent on paper from the real world, or whatever we are graphically representing. In more accurate terms, I should say, it is graphical representation. So I am making a graph or a picture here to represent my school. So this is known as map, and the art of map making is known as cartography. A lot of students, I know, oh, cartography, what's this? How will read this? But cartography, to be very simple, is a simple art of map making. Now, maps can be broadly defined into two categories. First is reference map, and next is thematic map. Now, what's the difference between reference map and thematic map? So, reference map is any map which shows natural surroundings or human-made objects which are important from the point of location. For example, if I am making a map of my colony, okay, the most important part of my colony is where my colony starts. There is a church, so it's a church here. So that's the reference point or the base point. Then you have thematic map. What is thematic map? Thematic map is geographical distribution of one or more phenomena that you can depict by various ways. So for reference maps, we usually use topographical maps. And what is a topographical map? Here is a sample topographical map. In this map, you can see there are small lines running around. These are small lines which are running. And these lines are known as contours. So these are contour lines And contour lines are, for example, there are some peculiar features about contour line. So they show the height and elevation. They are never straight. They never cross each other, and they always cross rivers. So for example, here is a contour map depicting various features. So in this, as you can see, this is a river that is flowing in. This is the main river that is flowing. Okay. So this region is the ridge. These regions are the valley regions. This is the river that is flowing, and this is the peak. So we can depict it. For example, this contour is 300, this contour is 200, and this contour is 100. If I draw a cross section of this contour on land, this will fall at a point 100. This will fall. So this is 100, this is 200, and this is 300. So this point will fall here, this point will fall here, and this point will fall here. Then this, and this will again come on 200, and this will come on 100. So I can say this is a contour or a mountain. So this is how we understand the concept of contours. The next important concept is in thematic mapping, where we are trying to explain the concepts in terms of geographical distribution of phenomena. There are various ways we use thematic mapping for. First is, for thematic mapping we use choropleth method. In choropleth method, what we do is we use gradient of color. For example, I have chosen red as a theme, so I'll choose various shades of red from light to dark, light red to dark red. Okay. Next is chorochromatic. So it's chromatic. In this, I'll use various colors. For example, this is a region. There are 5 regions. I'll use green, red, blue, and yellow to depict every region. And in case of choropleth, I'll use various shades of red to depict the region. Then is choroschematic. In choroschematic, what we do, we use symbols. For example, there would be a symbol this for well. Okay, there would be a symbol this for all the mountain peaks. There would be this symbol for all the areas having high sun rays or high sunlight. So we can use various methods in this case. Next is isopleth. Isopleth are lines that run parallel to each other, and we depict by means of shading. So shading by means of lines. Then you have proportional symbols. Proportional symbols means, for example, my locality has one post office, so I'll make a circle of this size. And the other locality has 10 post offices. So I'll make a bigger symbol which shows 10. So circle of this size, 1 mm, for example, shows one post office. A circle of 10 mm means 10 post office. And the last method is known as what we call as dot density. Dot density is mainly used for mapping population. For example, one dot depicts 10,000 people. So a village, for example, will have one dot, and a nearby metropolitan area can have, I say, 10 dots. That means 1 lakh of population. So this is how we define the various kinds of thematic maps. Now we have understood the types of maps, the methods we depict the map, but the basic question still lies here. Why do we need maps? What is the importance of having maps? So maps, what they do, a very large area on the ground can be depicted on the paper in a small form. So it's much more manageable and we can understand it better. Suppose any building project is coming up. If you give a map of it, it makes much more sense rather than taking the person to an open land and showing that here your plot would be or here your development would be. Maps also help us to show phenomena that are not visible to the human eyes. So if there is a very big piece of land, for example, if we talk about whole of the earth, I am sitting here. I cannot see a city in China, but with the map I can do that. It presents information concisely, so it's much more concise and easier. And next is a spatial relationship. So spatial relationship tells us how far, how close, and you are able to analyze the concept naturally. Now we understood why we need maps. Now my next question is, how can you make maps? How to make maps? Now this as I said is an art of map making, which is known as cartography. But how can I do that? There can be various ways. I can survey any area and do a map of it. I can take pictures or photographs, and based on that I can draw a map. What I can do is I can draw a freehand sketch, and next what I can do is I can make computer generated map. This is the latest technology in cartography these days, that is known as computerized mapping or computer generated mapping. Now whenever you have map, there are some characteristics which are essential for mapping. For example, here is a map. So here are the basic elements that we must know. First is, every map must have a compass or north. Then you have a legend. That means all the dots here represent cities. That means Beijing is a city, Calcutta is a city, Bombay is a city, Los Angeles is a city. Then you have the major grids that are passing in. This is the 0 degree equator, 0 degree, and this is the 0 degree or the prime meridian. And then we must have a scale. This scale means this much on the paper, that is half centimeter for example, on the paper represents this much kilometers on the real earth. So this is a kind of scale, or what we call as a scale. Now, so the most essential parts of mapping are, first, symbols or legend that we make here. That's also known as the key. Then you must have a scale, direction. That's another essential element that you must have. Then you have the coordinate system or the important grids that pass through the region. And then what is not mentioned here but is important is date created, title, author, and then you have the source information. So these are some of the important elements that are must for any map. Now since you have a map, what is important is reading the map. How will I read this map? So to read this map, I must have the knowledge of legend. So I must be able to read the legend or the symbol first of all. Then I must know what is the shape of what is on the map. So I must understand the symbols. Reading the symbols and understanding the symbols, they are two different things. Reading the symbols means here is a dot and here is a dot. So dot dot is same. And understanding the symbols is, dot means city, so all the dots on the map would represent various major cities of the world. And then what is the shape of the projection? That is very important. Now map projection we would be taking into a totally separate session where we'll be talking about why we need map projections, what are the major distortions. Anytime when you are covering a circular figure into a plane figure, or I should say a 3D figure into a 2D figure, there are distortions. Considering these distortions in account, we draw various projections. So for projections, we will be doing totally a separate session. Then the next important topic today is scales. We already talked about data, we talked about mapping. Now the final important section in this class is scale. What is the scale? Why is it important? And what do we do with the scale? So scale is all about distance. So all a story about distance. For example, this is my home and this is my school. Okay. From my home to school is 10 kilometers. Okay. So this is the actual distance on the ground, and I want to depict this distance on a sheet of paper. Now on the sheet of paper I cannot make a 10-kilometer long sheet of paper. So what I'll do is I'll take a standard sheet of paper of a size of letter size or any size, and I'll mark the scale. For example, 1 centimeter is equal to 1 kilometer. That means by using a scale, I'll draw a line of 10 kilometers is 10 centimeters, and 10 centimeters on that sheet of paper will depict 10 kilometers, and that would say this is my house and this is my school. So with a scale, it's basically about distance. We can understand how long we have to go, how far we have to go, what is the width and what is the length. So this is what we calculate using scales. Now scales are of three types. The most important is verbal scale, RF or representative fraction, and third is graphical scale. Now let's understand all three of these. Verbal scale means if I say 1 centimeter is equal to 1 kilometer on ground, 1 centimeter on paper is equal to 1 kilometer on ground, that is a kind of verbal scale. If I talk about representative fraction, what I am trying to do? 1 centimeter is to 1 kilometer. So that's 1000 and that's centimeters. So 1 is to 1 lakh would be the representative fraction. And what would be the graphical scale? So graphical scale is any scale which we draw in this form. So in this is a scale with different dimensions, but just to make sure what do we mean by graphical scale is. So this distance on basically, for example, this is 1 centimeter. So 1 centimeter here equal to 5 kilometer on ground. So this is what we can understand from this scale, and therefore the scale is 1 is to 2,50,000. So whenever we try to calculate map scale, what we try to do is we do map distance by earth distance or the ground distance. That is known as RF, representative fraction. So if I say 1 is to 2,50,000, what do I mean? I can say 1 centimeter on the map is equal to 250,000 centimeters on ground. So 1 centimeter is equal to 250 meters. Okay, or I can say 1 centimeter is equal to 0.25 kilometers, or I can say 1 kilometer is equal to 1 upon 0.25 centimeters, that is equal to 4 centimeters on ground. So these are the various ways of understanding the mapping. Now here is a map, here is a diagram. What I am trying to do is I will try to help you analyze this diagram. Now consider this diagram. In this diagram, what is important is A is the complete section, this is B out of A, and this is C out of A. Okay, so this whole is A, then this is B, and this is C. Now what I try to do, I zoom out B, so this becomes B, and this becomes C. Now I further zoom out C, so this becomes C. So basically in this we are talking about a big patch of land, then we are considering a smaller area and further a smaller area. So as we go on, what happens is RF decreases, a representative fraction decreases. So map on the far left, this is right and this is left. So map on the far left, that means I'm talking about this map. What does it have? It has the smallest scale. And when you have the smallest scale, you are depicting the largest area among the three. So this has the smallest scale and largest area, and vice versa, this has largest scale, largest scale and smallest area amongst the three. So this is one concept that you must be sure of. Now as we move from here to here, what happens is RF becomes half. Since RF becomes half, or we can say not half, sorry, it doubles out. Okay, so since this is causing doubling, what is happening is area is reduced by 1/4, or you can say 25% reduction in the area because of this. And similarly is the next case. So this is how we understand and analyze the maps. Now we are talking about various types of maps. Oh sorry, various types of scales. So this is the first scale. This is known as comparative scale. And this scale, what we try to do, I am matching miles and kilometers, and I am matching the zero for the same. So this scale, both of them are at a RF of 1,50,000, and this scale shows this much kilometers would be equal to, for example, half centimeter, and this much miles would be equal to 0.75 centimeters. So we are matching two different units. Then we have the diagonal scale. In diagonal scale, you have three components. First, we are considering the values on this 1, 2. Then we are talking about 0 to 10 here, and then further 0 to 10 here. So we are talking about three various dimensions. And finally is the vernier scale. In vernier scale, since we are talking about this value, I want to understand this value. So what I am doing is, I am measuring till here, so it's 2.4 till here. Okay, then it's on the slower scale, you can say it's 0.07. So if I add these values, that would give me on this lower scale, so the answer would be 2.47. And finally is the time scale, the last kind of scale that we would be discussing today. So in this time scale, so let me make sure this is comparative, this is diagonal, this is time scale, and this is vernier scale. So in this, what we are trying to do is, I am trying to match kilometers with minutes. 0 kilometers at 0 minutes. So 1 kilometer in 20 minutes. So 1 kilometer and 20 minutes are at the same time. So for example, if I am traveling 1 kilometer, I will take 20 minutes for it. And these match. Now how do we calculate reduction or enlargement of the map? So if I am reducing the scale from 10,000 to 50,000, what would happen? What would be the new size? It's simple to calculate. It would be original upon the new. So it would be 10,000 by 50,000, that is 1 by 5. Now it would be 1 by 5 of the original scale. So the area would be 1 by 5 square, that is 1 by 25 times. Now if I am enlarging the map from 1 lakh to 20,000, this was reduction of the map. Now the second case, when I am enlarging the map, what would happen? This is the scale. If I am enlarging it from 1 lakh to 20,000, what would happen? It would be 1 lakh by 20,000. So it would be 5. And 5 square would be increase in the area by 5 square, that is 25 times increase in the area. Now this is one of the simple things that I have talked about. Now if the map scale is 1 lakh and it is enlarged by 10 times, how will I calculate this? So I have a new scale which is 1 by x, and that equal to 1 by 1 lakh. Okay, so that means, how can I calculate this? So this is to, the new scale 1 by x is to 1 by 1 lakh, and that would be 10 times the new one. So I can do it as 1 lakh by x is equal to 10. So I can calculate as x is equal to 10,000, and I can say that the new enlarged scale would be 10,000. Now, some of the students ask, the RF is changing from 1 is to 1 lakh to 1 is to 10,000. So, how the scale is enlarged? So, it's simple way. Since the scale is smaller, it is depicting larger area, smaller area, and the RF is bigger. So, it's known as enlargement. And finally, when the map is enlarged, the RF is decreased. So this is what you need to remember. So if you are enlarging the map, what is happening is RF is decreasing. So if the original map has a scale of 10 centimeters is equal to 5 kilometer, what would happen is, if it is enlarged by 4 times, the new scale would be, so you are enlarging this by 4 times. So what would be the new scale? So new scale would be 1 is to 125, 12,500. So since you are enlarging it, there is the RF is decreasing. So RF is decreasing from 1 is to 50,000 to 1 is to 12,500. Now, if we try to classify scales on another basis, there are some other ways we can define the scale. First is cadastral map, revenue map. It's also known as revenue map. Then you have topographical maps. So cadastral maps are large scale maps. You usually depict 16 inches to a mile. Then you have topographical maps, which are single purpose, meant for one purpose, where you talk about 1 inches to 1 mile. Wall maps, which depict further large areas, 1 mile, 1 inch to 4 miles, and atlas maps, which are small scale and they depict a huge area on the Earth's surface. So these are the various maps based on the size of scale size or based on scales. Then we already talked about symbols. Symbols are very important while we do maps. In this session, as we discussed, we'll try to do a quick recap of what we talked about. So we started with what is data, types of data, idiographic and nomothetic approach. Then we talked about map, the types of maps, that is the reference maps or the base maps and the thematic maps. Why do we need to prepare maps? How we prepare maps? The various elements or essential arts of maps. Then we talked about scale. The most important thing is, a lot of people are very clear with, there are 3 types of scale: representative fraction, verbal and graphical. But this section is the most important topic, that is analyzing how do we scale a map with a larger area, what happens, and as the area becomes smaller, how does there is a change in RF, then the various types of scales. Then we talked about reduction and enlargement by means of RF, maps based on various scales, and the various symbols that are required for map. Hope you enjoyed this session. In the next session, we'll be talking about how to depict various relief features and what are the various kinds of projections, what are the most important projections, and which part on the globe is represented by means of which projection. Have a good day ahead.